All right, welcome to new 21. I kind of mentioned it at the end of the last video tutorial. If you made it that long, the last one was a long one. But I'm going to mention it at the beginning of this one too. You'll notice that there are not like 8 videos for this one. It feels a little bit different this week and next week actually. It is because factoring is such a conglomerate that it is broken into 2 weeks actually. So because of this, there are actually there are a couple videos. My dog's gonna bark in a minute. There are a couple videos for 20, 21, and 22. There's a worksheet 20.5, 21.5, and 22.5 where it's like extra practice, because realistically this is like the meat of this this course this week and next week. And you know, if you need to go back and review the video again and watch it twice, you know, so nice, do it twice, do that. If you need to go and do the independent worksheet or do another independent worksheet, please do that. So there's extra practice on it, and that's why. Okay, so let's get started on this factoring. So like I said in the last video, which I talked a lot in the beginning of it, I apologize, we didn't jump right into the math. Factoring is such an umbrella term. I really try to break it down into each subtopic. So we went over GCF, what factoring with the GCF looks like. This is going to be factoring special cases, and then we'll go on to the next thing in the next video. But this is going to be factoring special cases. You'll see the link back to polynomials in each of these. So hopefully you saw the link in the last one, and we'll talk about the link in this one as well. So let's get started. Okay, so I had kind of mentioned to you with polynomials in the last one where, you know, perfect squares. You saw the perfect square numbers in the last one. I think we had talked about like 49 popped up. The perfect square numbers are any numbers that start 1 times 1 and they go up, you know, whatever. And this is going to be another topic that your multiplication chart helps with, which that video is coming. But your perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Now you may say to me, like, how did you get those numbers? Well, first of all, I've been, you know, using those numbers pretty regularly for at least the last 12 years, if not before then. But they're very easy to get in just that. Number one, they'll be on that multiplication chart that I send you, and I'll highlight where you can find them. But number two, you can generate that list on your own, just by doing 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. That goes all the way up. 15 times 15 is 225. So that's usually where we go, just on a memorization base. And that is really, it's a good thing to have in your stored bit of knowledge. The reason why we have those numbers memorized, and they'll come up now, you'll use them next week, and then the following week, and then they'll definitely be of use in the last week. So you'll use these for the rest of this 6-week stint. But realistically, on the flip side, when you take the square root of any of these numbers, these are the only numbers that when you take the square root of them, they come out to be a non-decimal number. So the square root of 81 is 9, the square root of 144 is 12, the square root of 9 is 3. If you take the square root of any other number, you will get an irrational number, which is a decimal that never ends or never repeats. So, why are we talking about this? Why did I bring this up? Because if you look at these numbers, if you look at these quadratic problems that I gave you, these look completely different to the ones from the last video tutorial. So, again, that factoring conglomerate, the other ones we factored by GCF, okay? They all started with, well, they didn't all start with an x squared. Some of them started with an x to the third. Some of them had 2 terms. Some of them had 3. If you look at these, all right, some of them have 2 terms, some of them have 3, but what they all have in common is if you look at the first term and the last term, they are all perfect squares. Now, some of them are easier to see than others, so and I'm going to jump around for just a bit. Like number 3, it's very easy to see. Perfect square, perfect square. And PS, is going to be my abbreviation for perfect square. That's not at all a formal math abbreviation. That's just mine. Okay? But if you look at number 1, that's a little bit harder to see. While 9 is easy to see as a perfect square, x, or x squared, okay, that is, there's a 1 in front of that, right? While x squared is a perfect square, the 1 coefficient in front of it is also, but there's a 1 here, and that is also a perfect square. Similarly with number 2, that's one of those that we've talked about where it's like, it's kind of the one where it's like the y equals x, where the identity is there and it looks quirky, or it looks, maybe different, and you don't see it as for what it is, but it ends up being exactly, it falls exactly into what it, the y equals mx plus b. This is a perfect square, and this is a perfect square, and we end up having what we need to be able to factor it. Okay, so number 4, this is a perfect square, this is a perfect square. If we look at 5 and 6, 7, and 8, 9, 10, okay, again, we're only looking at the first term and the last term. And again, I'm just looking at the numbers, and I'm referring back to that list. 1 and 16, 1 and 25, 81 and 25, 25 and 36, both on that list. 1 and 1, 16 and 9. All right, and then the other thing I have to check for is that in these ones that have 2 terms, like in 1 through 4, that they're subtraction. So x squared minus 9, x squared minus 1, 36 squared minus 81, and 25 x squared minus 49. If it has addition, then it breaks the rules and it doesn't work anymore. We'll talk about that later on and probably in a live, but just trust me that the rule is that it has to be subtraction. So with this, the way this gets set up, and because it's a special case, okay, you can trust me when I say this, And our link back to polynomials, remember when we had this? Oops. And we said that the inners and the outers like dropped out and they knocked out, and we could just do like the first and the last. And this was our double distributive property. And we had 4 terms, and then we were able to simplify. And we got something that looked like that. All right, that is our link here. So we are basically starting with our start end. Okay, we are starting now. We are starting here. And so we have flipped the script. All right, so if we are starting with x squared minus 9, we're going to set up our 2 parentheses. Okay, and we are basically saying what are we going to multiply to get x squared? Well, we need an x and an x. We know that. X times x gives us x squared. And what is, and that's also taking the square root of x squared, right? The square root of x squared is x. The square root of 9 from our perfect square world is 3. Okay. And in order to multiply to get a negative, we need one of those 3's to be positive and one of them to be negative. Now, from all our work with polynomials in the review section, let's just check our work here. Okay, our double distributive. We're going to do this. We're going to get 4 terms, right? So x times x gets us x squared. X times negative 3 gets us negative 3x. We're going to distribute that 3, and we're going to get positive 3x. And then positive 3 times negative 3, we're going to get negative 9. What happens to the negative 3x and the positive 3x? They knock out, and I get x squared minus 9. And there you have it. So our answer, this is a whole lot of nonsense. What's our actual answer? It looks like this. All right. So what's our answer going to look like for this? We have an x, because we have 2 terms in each of these parentheses. Okay. This is our perfect square, so we take the square root of it. The square root of 1 is 1 and 1. And we have 1 positive and 1 negative to knock out those middle terms like we need to happen. And we are done. All right, number 3. Set up our parentheses. 2 terms in each. 36x squared, so we're going to take the square root of both of those. So 36 gives us 6 and 6. X squared gives us x and x. The square root of 81 gives us 9 and 9. And again, to get all of our middle junk to knock out, we get plus and minus. All right, number 4. All right, our first term gives us 5x and 5x. 49 gives us 7 and 7, plus and minus. All right, so now down here with the ones with 3 terms, it's a little bit different because we don't want those middle terms to knock out, but we still have these perfect squares to play with that help us. So for x squared, we still get x and x because x times x gives us x squared in that first spot. For 16, we still get 4 and 4. Now we know if we want to get the middle to knock out, to zero out, we want the plus and the minus. But if we don't want the middle to knock out, we know we have to play with our signs. So if we want to add to 8, so this is our inners and our outers, that double rainbow we talked about in the polynomial and the review part of this week. It's this part, this inner and this outer, this double rainbow underneath. Okay? So if we want, and that goes with our middle term. Because remember, this goes with this, and this goes with this. So these two both go with this guy. Okay, he's double-edged sword. So if I want them together to add to 8, what do my signs need to be? I have 4x here and 4x here when I multiply, right? 4 times x gets me 4x. X times 4 gets me 4x again. How do I get to 8x? They both need to be positive, right? So let's check our double distributing. X times x gets me x squared. 4 times x gets me 4x. X times 4 gets me another 4x. And then 4 times 4 gets me 16. So notice, this one is correct. This one is correct, right? And then in the middle, is this one correct? Does that get me plus 8x? Yes, so I'm good to go. All right, let's do it again. We get x and x. 25 gives me 5 and 5. All right, and now we just have to play with our signs. We want negative 10x. So with this one and this one, our double rainbow, how am I going to get negative 10x? What am I going to do to get negative 10x? What signs do they both need to be? A negative and a negative, right? I get negative 5x here, and I get negative 5x here. And this makes sense, right? Because when I check my work, x times x gets me x squared. Then I get the negative 5x, the negative 5x from both of these. But then watch, negative 5 times negative 5 still gets me positive 25. And I needed the positive 25 because a negative times a negative gives me a positive 25. And then when I combine these, I get negative 10x, which is what I needed. So I'm good to go. All right, let's look at number 7. All right, the front is going to be 9x and 9x because I have that perfect square going for me. The back end is going to be 5 and 5. Since I'm working for this negative 90, what do you think the signs are going to be? Negative? I like it. All right, so let's check our work. 9x times 9x is going to be 81x squared. I have these two middle terms. I'm going to have negative 45x and another negative 45x. And then negative 5 times negative 5 is going to be positive 25. These together will be negative 90x. Check. All right. Next one. 25x squared is going to give me 5x and 5x. 36 is going to give me 6 and 6. Positive 60x is going to give me a plus and a plus. So when I check my work, 5x and 5x is going to give me 25x squared. These two middle ones is going to give me plus 30x plus 30x. 6 times 6 is going to give me plus 36. These together is going to give me positive 60x, and that was what I wanted. All right, down at the bottom here, last two. I'm going to get x and x. I'm going to get a 1 and a 1. This is a positive, so I'm going to have both positives here. Checking my work, I get x squared plus 1x plus 1x plus 1. Combine those, I get x squared plus 2x plus 1, and that checks with my work up here. Final one, I get 4x and 4x. I get 3 and 3 from my 9. Positive in the middle, so I'm going to get both positives. Checking my work, I get 16x squared plus 12x plus 12x plus 9. I get 16x squared plus 24x plus 9, and that checks. Make sure you check out not only the independent worksheet, but also the extra worksheet that I put up for you. The more, remember, practice makes not perfect, but permanent on all this stuff. The more practice you do with this, the better you will get, the more muscle memory you will get. Make sure after you try this one, you go on to the next one and you let me know how it goes.